Polynomials are an important part of algebra, and a big part of that is that we want to learn how to graph polynomials. And so here we're going to talk about how to graph factored polynomials, because once it's factored, we understand where the intercepts are. So really most of the work's done for us, but there are two key concepts we have to consider. The first concept is end behavior, and the second one is the multiplicities of zeros. Alright, so let's first discuss end behavior for this example in particular, where we're trying to graph x times x minus 1 squared times x plus 3. And to explain end behavior, I'm going to look at this graph of a polynomial that's not the polynomial that we're dealing with. When I refer to end behavior, what I'm talking about is what's going on as I go out towards the infinities. And so the notation is x arrow infinity, meaning as x goes out towards infinity, what is my function doing? And in the other direction, as we go to negative infinity, what's my function doing? I think it's reasonable to say that we call this the right behavior as I'm going out to infinity, and the other way is the left behavior as I'm going out to negative infinity. And behavior is a good term to use because we're discussing how the function acts as we go out towards infinity. How does it behave? So in this particular one, notice that as x goes out this way, my function is going up. So as x goes in infinity, my function value, f of x, approaches infinity. And in this particular one, as I'm going out towards negative infinity, my function is going down. So as x goes to negative infinity, my function is going to negative infinity as well. The polynomial end behavior is actually very predictable. If your polynomial is f of x equals a x to the n plus some stuff like this, the key point here is your degree is n and your leading coefficient is a. Okay, those are the two key ingredients to this. Then I already know a lot of stuff. So look at this example here. On my right behavior, I went up, or I went towards infinity. My left behavior went down towards negative infinity, and that's exactly what happens for an odd degree polynomial. In my chart here, I'm assuming here that my leading coefficient is positive. Okay, so a positive leading coefficient, this is what's going to happen. If you have an odd degree, your right behavior is going to be up. What that means is that as x goes infinity, f of x goes infinity as well. And your left behavior is going to be down. So as x goes to negative infinity, your f of x also goes to negative infinity. Just like that. Okay, so that's the odd case. So I already know from this example that I had an odd degree polynomial because of the behavior. Okay, now for even degree, so if you think like a quadratic, which we've spent some time with, that's a parabola. If you think the parabola ends up on both sides, so the right behavior and the left behavior are both up. So that means as x goes to infinity, my function is going to infinity. And as x goes to negative infinity, my function is going to positive infinity again, right? It ends up on both sides. Okay, so that's end behavior. So now if I'm thinking back to my original question, and if I multiplied all that stuff out, what would I get? So I get f of x equals, well, let me think here. I have an x, and then x quantity squared, so that's like an x squared, and then times another x. So if I multiply all that out together, my first term, which is the only thing I need to worry about here for behavior, is going to be x to the fourth plus some stuff, okay? Because, remember, again, if I'm distributing, I have four x's being multiplied together. That's my highest degree term. So I have a fourth degree polynomial, which tells me then what about my behavior? Well, according to my chart, I can say that since I have an even degree, right, this is a degree 4, it's even, I'm going to follow this column of my chart. As I go to the right, I'm going to go up, and as I go to the left, I'm going to go up. Okay, so I already know the end behavior. So I already know a part of what this graph looks like. I know that on the ends, it's going to be up in both directions. Okay, now the second thing we need to discuss here is the multiplicity. Once we have the multiplicity, we can graph this thing. Now multiplicity, what we mean by that is if you have a factor, x minus c to the k power, okay, here we have c is a 0 with a multiplicity k. Alright, so we have a 0 here, c is my 0, but the multiplicity is k. That means the number of times that factor appears in my factoring. And that affects the graph. So let me give you two quick examples to show this. So let's let f of x be x minus 1, and let's let g of x be x minus 1 quantity squared. Alright, now let's look at the difference of these two graphs. So x minus 1, we know is just a straight line that passes through at 1. Not a big deal. But so I had a 0 at 1, and there it is. Okay, it passes through like that. Now in g of x, I have a 0 at 1 still, but this is a parabola. So when it hits down, 1 is my vertex. It hits down at 1 and bounces back up. And that's exactly what happens with multiplicities. Okay, so you can say this. If you have the multiplicity of k, if k is odd, then your function is going to pass through at that intercept. So we see that here with x minus 1. X minus 1 has multiplicity 1. The 0 at 1 has multiplicity 1, so it just passes straight through. But then when I look at x minus 1 squared, I have a 0 at 1, but since it has a multiplicity 2, which is even, it bounces. The graph bounces off. Another way of saying that, and this is a mathematical term, it kisses. It kisses the axis. Okay, so then I think back to my polynomial, which again was f of x equals x, x minus 1 squared, x plus 3. I can make a quick chart here of my zeros and their multiplicities. All right, and let's think what we have. I have a 0 at 0, and it only shows up one time in my factoring, so it has a multiplicity of 1. From here I have a 0 of 1, and it has a multiplicity of 2 because it showed up twice in the factoring. And then lastly I have a 0 at negative 3 with a multiplicity of 1, because you can imagine this is to the first power. X plus 3 only shows up one time in my factoring, so there it is. I have 3 zeros, 0, 1, and negative 3 with the multiplicities 1, 2, and 1 respectively. Okay, so what I know that then is that in the graph, at 0 it passes through, negative 3 it passes through, and at 1 it bounces. I'll say kisses. Okay, so this gives me a lot to consider. I think I know how to graph this function now. Let's put it all together. I'm trying to graph this function, and what I know is that I have zeros at 0, at 1, and at negative 3. Okay, there are my 3 intercepts. I also know the behavior. Remember we said this was a 4th degree polynomial with a positive, so that means that going out to the right is up and going out to the left is up. Now turning our attention back to the zeros and the multiplicities, remember that we had 0 as a 0, multiplicity 1, 1 with a multiplicity of 2, and negative 3 with a multiplicity of 1. So that tells me that at negative 3, I'm passing through because I had an odd multiplicity. So it's going to dip down like this. It's got to come back up to the 0. 0, does it pass through or bounce? Well, it's an odd multiplicity, so it's going to pass through. But then at 1, since 1 has an even multiplicity, it's going to bounce like this. And there is a good graph of my function. The only thing that I have to worry about is, did I really scale this part, this middle part, well enough? Okay, now I want to do one more example, and we can go through it much quicker now because we know a lot of this. And let's just see what we get. Okay, so this time we want to graph g of x, which is negative x plus 2 quantity squared times x minus 1 times x plus 1 times x cubed. That's a lot. All right, so let's first think about the behavior. If I were going to multiply this thing out, all this together, what would I get? So I know g of x is going to be, well, it's got a negative out front, and then I have, let's see, x squared times x times another x, so that's x to the 4th times x cubed. Remember, you add the exponent, so x 4th times x cubed. I'm going to end up with an x to the 7th plus some other stuff that for this part doesn't really matter, right? We have g of x equals negative x to the 7th plus, that's all we needed to know. Okay, now what we said was, if you have an odd, then the right side goes up and the left side goes down. That's what we said, and we would be correct except for one thing. Here, that chart was for a positive, but here a is negative. So if a is negative, what do? You flip your chart. So the right behavior is not up, it's down, and the left behavior is not down, it's up. Okay, so we flip that around. All right, now let's look at the multiplicities. I have a 0 at negative 2 with a multiplicity of 2 from this first term. I have a 0 at 1 with multiplicity 1 from the second term. Another one at negative 1 with multiplicity 1. And then I have a 0 at 0 with multiplicity 3. Okay, so then that tells me something. I already know then I'm going to bounce at negative 2 and pass through in the other places. Okay, so I think we're ready to graph this thing. So I have zeros again at negative 2, negative 1, 0, and positive 1. There's where my zeros are. I also know the right behavior is down, so it's going to go down like that. And on the left is going to go up because this is an odd degree polynomial. They're going to end up in opposite directions. Okay, so now I just got to figure out the middle. That's where my zeros and multiplicity come into play. At -2, I'm going to bounce. So I hit -2 and I bounce up. At -1, since I have an odd multiplicity, I pass through. At 1, I have an odd multiplicity, so I pass through. And at 0, I had an odd multiplicity, so it passes through as well. And with a higher multiplicity, what it'll tend to do, let's see if I can get this a little bit better, is it'll tend to flatten out a little bit around that intercept and then go down. Alright, so there's a pretty good graph of what g of x looks like. And we did it pretty quickly. Again, we just need to know what the end behavior is, the zeros and the multiplicity. Since it's factored, we already have the zeros available, and it's pretty simple. If you have any questions on this, I'd be glad to help. I would love to help. I want you to understand, and thank you for watching.